Hi, today we're going to go over the build of an Eggtimer Quasar flight computer. The Quasar is a new computer as of the end of 2022, beginning of 2023 from Eggtimer, and it is functionally a replacement for the TRS computer, but it adds a bunch of new technology and functionality. It's a really amazing new product from Eggtimer, combining a 3-output flight computer, a GPS radio tracker, and data logging and telemetry into one single device, which is pretty darn cool. So we're going to go over that build today. A lot of parts. This is my setup. I use a Hakko FM203 soldering station. You don't need anything like this, but I have to admit, for a build like a Quasar with so many different parts and pieces, this is a really nice setup to have, and I do recommend having something a little bit more than just a kind of the Radio Shack soldering iron. I use Panavices, a silicon mat, which in this build is pretty handy, and I use a 0.5 millimeter conical iron with my own spool of Kester 0.02 inch soldering wire, which is the same stuff you get in the kit. So unpack your kit. It comes in a pretty thick blister pack compared to a lot of the other ones, but a lot of parts and pieces to go over here. So pull everything out on your workstation, get them laid out, and we definitely want to do an inventory here. It comes with a pretty lengthy checklist, so get everything out of the packages, get everything out of the anti-static bags, and just get them laid out on your work surface, and do a real inventory here. Do actually check everything off the checklist. Mainly, I'm not too concerned usually when I get a package from Chris whether he's got all the parts in there. I've yet to have a time when he didn't give me all the parts, so that's not the biggest issue. The main thing, especially with a build like this, is identifying all your parts. There are a couple new parts that I haven't seen before in some of his packages, so definitely this is the opportunity to identify those. And this module does combine a lot of different functionality. So while you're doing this part, get everything laid out and identified. I like to cut out the Wi-Fi SSID passcode and put it to the side. Later on, we'll just write it right on the chip after we test. We'll write it on the Wi-Fi module, but for now, put it to the side and make sure you don't lose it. So this is the new Quasar parts list, and we're going to be doing the Rev G3 version build today. First thing up is your PCB with a GPS antenna already attached. Very nice. It makes your life a little easier. Put that to the side. The next thing up is your RF module. Put that to the side. Then we have the Wi-Fi module. It's a large silver chip on top. Easy to identify. Next up, we've got the EEPROM. It's an 8-pin chip. Now, a lot of these 8-pin chips look identical, so make sure you check the markings on there. That should have a 24C512, because the next one up is a IO expander with should end in 9536, and it looks very, very similar. This is a voltage regulator, a 3.3 volt, pretty distinctive and very much like the other builds. These are the 3 driver chips. They're also 8-pin chips, so make sure you really identify them. And here's where you want to be careful. You want to make sure you make a big distinction between that FET that we just showed, marked with 13 at the end, and the rectifier, which should have FD20. They look identical except for the markings, so be careful there. And then these small FETs are easy to identify. You only need one of these. He gives you 2, but they look almost like the regular chip, but very small. This is the LED, and it's also very distinctive, so not too hard to figure out. This is the buzzer, which is new. I haven't seen one of these before in any of Chris's builds, but this is a surface-mounted buzzer, so that should be an interesting new addition. Now we're starting in with the capacitors. These are the 0.1 UF capacitors, and this is what is referred to as a paper carrier. This white paper carrier is what you're looking for when you're looking for the 0.1 UF capacitors, because the capacitors look very similar. These are the 10 UF, and this is a clear plastic carrier. So very much make the distinction. They look very, very similar. The 10 UF ones are a little bit bigger. Now we're going to get into the resistors. These are 330 ohm resistors marked 331. You need one of these it gives you 2. So all of these should have 1 extra. Next up, you've got a 1K set of resistors marked 102. You need 1, you get 2. Next up is the 4.7K resistors marked 472. You need 3 of these, you get 4. Then after that, you're going to get 10K resistors marked 103. You need 4 of these, you'll get 5 in your package. Then is the 22K resistors marked 223. You need 1 of these and you get 2. And then finally, you get a bunch of 100K resistors. They are marked 104. You're going to need 3 of these and you get 4 of them. Next up, you do get some through-hole resistors. We're not using these for anything but the wire. The wire will be used to mount the Wi-Fi module. And then you get a 3x1K resistor SIP package. It's this yellow component right here. And then a bunch of angle headers, some straight headers, and some shorting jumpers that we'll use later on near the end of the build. And you do get a 6-pin terminal block. You get the antenna, which is specific to this build, a stubby antenna. And you get some soldering wire, which if you don't have your own Kester wire that's similar, I would recommend using it. So I like to set up the board, make sure everything's nice and neat before you start. Like I said, I use a pan of vise. Wow, it makes things so much easier than taping things to your work surface. I can't recommend one of these enough. I use a couple pairs of tweezers, a pointy pair and kind of a flat pair throughout these builds. Once again, just makes life a lot easier if you have both kinds. So first up, mount the board into your vise, and then the first component up is the EEPROM chip. Now, make sure that small dot lines up with the square. That's pin 1 on the silk screen onto the board. You have to make sure this is lined up properly. This one's pretty easy though, very visual. You can just line up that dot, make sure it's going into that square. Tin one of the pads. We're going to do this in real time here, and keep the heat on there, and then move the chip into place, tacking it in with that pad you just tinned. Make sure everything's lined up. All the pins on the chip should be squared onto the pads, and that's it. Once it's tacked in, you can go ahead and solder on each pin to each pad. Now, you don't need a huge amount of solder here. You just need enough to get a little bit underneath the pad. You'll see it kind of seep under there and give you a good connection, and then a nice little tent of solder across the top of the pin. Go back and solder that original pin so there's enough solder there. And that's really all you need. You don't bridge any of the pads, don't bridge any of the pins. You don't need a huge amount here. Just a nice, neat soldering tent. So once you get this EEPROM in, we're going to move on to one of the first surface-mounted small components, and that's a 0.1 UF. Remember, this is in the paper carrier, and it goes in that spot marked C104. We'll do this one in real time as well. Same thing here, just tin one of the pads, take your tweezers, move the component into place so it's squared up between the pads and not off to either side. And then once you're comfortable in the placement, take the heat off, and it will be tacked to that pad. Then put your board the way you like it. This is one of the benefits of the vise. You can move things around, and then go ahead and solder the two sides. Once again, not a huge amount of solder. You just need enough to get a little bit underneath onto the pad and to get a nice little tent to hold the chip on. Next up, you've got this IO expander, which is another 8-pin component chip. It looks very similar to the EEPROM. It looks very similar to the driver chips. Make sure you've got the right ones as we're moving through here. Now, there is no bevel, there is no marking on this chip to allow you to kind of determine pin 1. So you have to have the writing kind of facing the silkscreen writing on the board. It's kind of opposite. That's the only way to really tell whether this component is in the right orientation. So, and it's in the same orientation as the previous EEPROM chip. The writing's all going opposite. So make sure you have it properly oriented before you tin one of the pads and tack this one in. Now in this case, I didn't like where it was, so if that happens, just heat up the pin and pad that you just tacked in and move your chip back to where you want it. In this case, I felt it wasn't square, so I put it square. Once you're happy, go through and solder the pins just like the EEPROM chip, and you should end up with a nice little slender tent, a little bit of solder underneath the pad, but not an excessive amount that would cause any of the pins to bridge each other on the same side of the chip, or to go up underneath the chip and bridge to the other pads. So once we get past this particular 8-pin chip, we're going to speed things up. We're not going to, you don't have to watch this in real time from now on, but I wanted one more in real time so you can kind of see how these go in. And we'll do one more of the surface mounted resistors in real time as well, and then after that we'll start speeding these things up. In this case, you've got a 10K resistor going down at the bottom of the board there. Just tin one of the pads, put it in place, and then securely solder the component onto the board with a nice little tent and a little bit of solder underneath, and nothing bridging underneath the component. And now that we've gotten past this one, we're going to speed up the video on all of the surface mounted components. So it's going to go pretty fast, but you've got two more of the 10K resistors at the top of the board above the EEPROM and the IO expander. So solder those in place. And then you're going to end up next doing so this is a FET, and it's a really tiny 3-pin FET. It looks a little bit like the regulator, but tiny. So tin the single pad and then tack the FET in place, and make sure the other 2 pins are on those other 2 pads. It doesn't quite sit square on those 2 pads in the middle. They're kind of on the edge, so make sure you've centered it properly. Once you have, go ahead and solder all 3 pins on securely with a nice tent over the pin, but not enough to bridge underneath the FET or into any of the other components. After that, you've got another 10K resistor right next to that FET. Solder that one on, and then you have some 4.7K resistors marked 472. Get those tacked in and soldered on properly. And then finally, on this particular section, you've got a 0.1 UF. This is another one of the capacitors in the paper carrier, and solder that in place. Next up, we've got the driver chips. There's 3 of them. There's a bevel on one side. That bevel has to line up with the square silk screened on the board. That's pin 1. The other way to kind of determine you've got it right is the writing should be against the silk screen, just like the other 8-pin chips. I'm doing all 3 at the same time here. So tin the large pad on the opposite side from the pin 1, and then get your chips put in place, lined up properly, all 8 pins nice and square onto the pads and centered. And in my case, as I said, I'm doing all 3. I'm attacking them all in at once. Just makes it easier to solder them in. The instructions will tell you to do them one at a time, but I prefer to get all of the pins, all the chips onto the board at the same time. Once you have all 3 of them lined up properly and tacked in on that center pad, you'll just go through and solder each pin just like the EEPROM and the IO expander. And in this case, we will speed that up because you don't really feel like sitting here through endless loops of soldering pins, but it's the same process just like the other chips. Get all of them soldered securely, and then we'll move on. Okay, once you get the driver chips in, you've got a couple more resistors. These are 100K resistors marked 104, just to the other side of them. Go ahead and solder them in securely. Then next up, we've got the voltage regulator. So for the voltage regulator, tin the large pad and then move the component into place with the large pin on the pad and all of the other 3 squarely centered on the other 3 pads. Now, in this for this component, you do need to wait 30 seconds at least between soldering each pin in order to make sure that you don't overheat the whole chip. Now, we're not going to do that in the video. I did do that when we were soldering this in, but in the video we're going to cut out the waiting time in between each solder joint. But for each one, just much like the FET, get a little bit of solder underneath, heat up the pin, and then a nice tent over the pin. There was a 30-second pause, and then do the middle one and the one on the end. We're just speeding this up for you. And then once you have all of the 3 small pins done, go back and put a decent chunk, a decent tent of solder onto the large pin. Not only does that help secure the voltage regulator and make sure you get a good flow of current, but it also acts as a bit of a heat sink for the voltage regulator. Back to some of these surface mounts, we've got a 102 resistor, that's a 1K, and then a 22K resistor, that's Mark 223. Get those put in place. And now here's your first 10 UF. These are kind of a little bit larger, a little unwieldy to handle compared to the point ones, but put that 10 UF capacitor in right. And you can see here what happens if you heat up the whole chip by mistake or don't have it tacked in properly. The whole thing just dislodged. If that happens, just heat up your pads, heat up the component, get it off, clean the pads if you need to, put the component back in place, and then solder it securely. So not a big deal. Just wanted to keep that one in here because sometimes you do mess up and it's not that hard to fix it. So there we go. Now we've got the RF module, and this one is a little bit more complicated than some of the other components we put on. Tape it in place, and what you need to do is make sure that all 7 of those little notches are lined up on the pads on the bottom and the 2 on top. Once you've got it lined up properly, tape it down securely, and you want to get at least a couple pieces of tape here right to the edge of the RF module board, because if you don't, some solder could get on the small components and ruin it. So make sure that the entire board is covered with tape so that you don't get any splash on top. Once you've done that, you have to solder each one of these little notches to the pad. So heat it up, get a little solder in there. Now you don't want to get a lot. You just need enough to bridge that gap and the pad, and not enough that goes way up in the hole or all underneath and bridging and ruining the RF board. We're going to speed it up here because once you do one, it's all the same. But you do, like the voltage regulator, make sure you're waiting 30 seconds minimum between each one of these soldering joints. You cannot do them right away or you'll heat this chip up and you'll ruin it. So get all 7 of those, turn the board around, and do those other 2. 30 seconds in between, just enough for a nice little tent and a good connection. Here's what the bottom of the board looks like when you have finished all of these components. And now we're going to go to the top. You're going to start with another one of the 10 UF and a 0.1 UF. So you can put them on at the same time, but just make sure you don't mix them up. Then you've got a 330 ohm resistor here. And then the next thing up is the LED. Now note on the LED you've got these green spots. Those have to line up with the triangle on the board, the diode side. So make sure that you've got the LED oriented correctly before you put it on. Once you've figured out the correct orientation, then it goes on just like the other surface mounted components that we've been doing, the resistors and capacitors. Just tin a pad, move the LED into place, and then securely solder each side just like you would any of the other resistors and capacitors on the board. Now, once you finish the LED, we've got, we're getting close to the done with the surface components. There's a couple more, but first thing we have to do is get this buzzer on, which is a little bit different than the through-hole buzzers we've seen in other ones. So you line up that notch, that cutout notch, to that non-soldered pad on top, and then once you ensure that the buzzer is lined up properly, just like the other surface components, tin a pad, line up your buzzer so that all three of the triangular metal pins line up squarely on the triangular pads in the corners, and then after that it's just a matter of soldering each corner securely. You don't need a huge amount here at all, just enough to get the pin securely connected and to the board, and enough to hold the buzzer on. Once you've got all three pads, note that the fourth corner there, the one that you lined up with the cutout notch, does not have a pad. You don't solder that one, just the other three corners. But once the buzzer's on, you're back to surface mount. This is another 10 UF capacitor. Get that one put in place. We're getting close now to the end of the. There's a lot of surface mounted on this chips, a lot of surface mounted components. Next step up is the Wi-Fi module, which can be a little intimidating. I get it. So I take the. I like to make sure my mat is clean. I wiped it down with isopropyl alcohol, and then you line up your through-hole resistors, because you're going to need them all. Then I take a piece of tape, like Chris says in there, about a 1/4 inch wide, give or take. I just cut it off a larger piece that I stick on the table. At least 3 inches, but it can be longer, as long as you get that chip down and flat on the board. Now, here's why I like the silicone mat. Chris tries, in the instructions, there's a discussion of, trying to hold that pin straight, solder it while the board. The nice thing with the silicone mat, I just stick it right in the mat and get that first solder in, that first pin kind of tacked to the Wi-Fi module. And once that pin is in, it can be a little difficult to heat up that first pin. But you don't need a whole lot of solder here. There we go. Now, once it's tacked to the board itself, I like to then do the opposite corner personally. So cut this off about halfway with your clippers. It's not hugely important the amount you leave, because there's more than enough wire. But by kind of sticking the pin in the mat on the first pin, so it's solid, and then the second pin I put in the opposite corner stuck into the mat. Now once I solder this pin to that hole, the chip won't go anywhere. It's kind of functionally, stuck. The pins are stuck into the mat, and it gives the whole module kind of a opportunity to stay in place, even if you take the tape away. So from here on out, it's just as simple as putting each successive pin in, solder it to the, make sure they're kind of straight, solder it to the hole with just enough solder to hold everything. And I'm going to fast forward everything here, so it's going to kind of get a little wild. And then just cut off at the halfway point, clip off the actual capacitor, and then continue on that all the way around the board until you've got all 8 pins done. Apologies, it got the focus went out on the side camera there for a little bit, but you get the idea from the split camera here that you're soldering them in all the way around until you have all 8 pins and all 8 holes soldered properly. Then take the tape off, and inspect all of those joints. Kind of pry it out from the mat. Inspect all your joints. You should have kind of some long pins on the top of the board, but very long pins on the bottom, and they're all going to be a little bit uneven at this point. Just go through and even them all out, so that makes it a lot easier. I like to stick my finger over the clipper so the little pieces of pin don't go flying all over the place. And make sure when you're done with evening them out, you vacuum up all those little pieces of wire that are that are sitting on your work surface. You don't want those getting stuck on anything, or getting underneath a chip, or getting underneath the module or anything. They can definitely create, as Chris calls it, the vias underneath the boards. Once you've got them all relatively the same length, I personally find the tweezers to be the easiest way to go ahead and straighten them all out, relatively speaking. Make sure they're vertical in both directions, both to each other and to the chip itself. Just makes it a lot easier later on when we go to put this into the PCB. So at this point, I find the easiest thing to do is, before I clip the top, once again, go through real quick, make sure you vacuum up all of those little pieces of metal that are on the work surface. Now we're going to mount the Wi-Fi module onto the board itself. So now that you've got all your pins in the right length and they're all straight, just take the Wi-Fi module and you're going to actually get all those pins into the board. Make sure it's oriented properly. The long end has to go towards the end of the board, and the silver part of the chip has to go up. So get it on there. It might be easier sometimes to use your tweezers to kind of, if you've got some pins that are a little bit off, or they're not perfectly straight, get it close, use your tweezers, move the pins, jiggle it around, whatever you need to do without breaking it or breaking the pins. Be gentle here. And then it should sit level. It doesn't necessarily, it will not sit flush, right? You want about a 32nd of an inch between the Wi-Fi module and the board itself. So it should look like that. Flush or level, but not flush to the board. And once you've got that in and you're comfortable with it, turn it over and solder the two opposite pins, whichever two you feel like doing. And then once you're done with that, take it out, make sure everything's still good. Go ahead and check all of your that it's level, that it's not flush, all that sort of thing, and then go ahead and solder the rest of the pins in. We'll speed this up here because it's all the same soldering technique at this point for the rest of the pins. Go back, make sure they're all well soldered. You get a nice little tent on top of each one, then you're going to turn the board back over, and I like to make sure that each one of the soldering points on the top are also good, because if you don't have a good connection to those pads, it's going to mess up. I've learned that from making that mistake in the past. After that, go through and going to clip off these wires. I like to use a pair of tweezers to kind of control the piece you're cutting off, because they have a tendency to go flying. They hit you in the eye. Use eye protection here. Just be careful, not only for your safety, but also because those small pins, if they end up on the board somewhere, could short something out, especially if they're underneath the Wi-Fi module. So be careful that you're controlling them and cleaning them off. So go through and go do the top and the bottom. Next up, we've got a FET and a rectifier, and they look absolutely identical except for the markings. The first one up is the FET, and it's marked FQ13 on there, so make sure you have the proper one. And to line it up on the board, that metal backing lines up with the thick silk screen line on the PCB. So just insert the chip, tape it down, and then turn it over and solder the 3 pins. Once again, we're going to speed this up. Pretty simple through-hole soldering here. Once it's done, same thing. Control the pin, clip it down to the board, and your FET is in. Now, once for the same thing for the rectifier, line up the metal side to the thick line on the silk screen on the board, tape it down, turn your board over, and solder that one in. Key piece here is just making sure, as I noted, that you have the right one in the right place between the FET and the rectifier. Next, I am going to put the terminal block on. I know Chris often recommends not using terminal blocks. I personally like using them, so make sure the holes that you're going to put the wires in are facing out. Tape it down, and then solder all 6 pins securely to the board. Next up, we're putting angle headers and straight headers on. Now, this angle header, I like to put a spare DuPont connector on it to keep it level, because it can tilt onto the Wi-Fi chip. It depends on how high the Wi-Fi chip is. This makes sure that you have exactly the right clearance for when you'd want to connect a wire to it later. So tape it down with that, and then solder the 3 pins on the other side. For the 2-pin connectors, I find it easier to just put the pins right through the tape and tape it down to the board straight, because there's no angle here, so it makes it easy. So do that, and then solder it securely to the board. Now this resistor, this SIP package, has a little dot on one side, and that goes to the square on the board, and the writing faces towards the Wi-Fi module. So put that component in, tape it down securely and straight, and then flip the board over and solder all 4 pins to the board securely. Finally, we have the last 2-pin connector. Same thing, just put the tape through the pins through the tape the 2-pin connector down, and solder those 2 pins on the other side. Now, once we get through with this one, we're pretty much done with the soldering components we have to do. We do have to mount the antenna, which is just you put this there's like a bevel on one side. Make sure that goes on the side of the Wi-Fi chip module, and then it's a threaded piece of metal on the antenna itself. So just put the screw through the hole and screw that down tight, and that is pretty much it for the board. I'm going to use a standard JST connector here because I plan to use this with a 2S LiPo. So put the wires through. I'm using a pair of helping hands, the red wire to the plus side, the black wire to the negative side, and you should be good. Do check your polarity. Some of the cheap ones can be incorrect. Now, so for testing it, you just connect your battery. You should hear some beeps. Connect to Wi-Fi, and you can see on the left that it's all good. It's the channels are all there. I've put a couple of Christmas lights in, and it's getting a GPS signal. You can see that on the phone screen on the left, and on the right we're checking to make sure that it's connecting properly to to the LCD GPS. Sometimes you have to refresh it to make it connect a little easier, and there you go. That means the RF module is working right, the Wi-Fi module is working right, and the GPS is working correctly. And so you can flip through your screens on the LCD to make sure everything's proper. And then we're going to test the deployment channels. The first, you go to the test screen on your web browser, and then choose which one you want to test. We'll test the drogue first. You put the code in and then hit test. Let it count down, and we're using some Christmas lights here to see if everything works properly. It should light up, and it does. So drogue is working well. Then we're going to test the main channel, and same thing. Choose main, put your code in, hit test, and if all worked well, we should get a light on our main channel. And we do. So we can be pretty confident we've done everything properly here. Obviously, it needs to be flight tested, but everything seems to be working fine. Wi-Fi, RF, and our GPS all seem to be functioning, and our deployment channels. So looks like we did a pretty good build here. Hopefully this works out for you as well. It's a bit of a complicated board, a lot of pieces, so take your time, read the instructions before you start, and be familiar with your parts and pieces before you embark. But if you have any questions, put it down in the comments, and hopefully it works out for you. Thanks.